This lab is about compensation and correlation. So when you check the model here, there is a inventory which is connected to order by a request and response. So when the inventory service has a problem, the order service gets affected by the problem it happened here. But for delivery, this policy is only linked by publish and subscribing. So even though the delivery service is not working, it does not affect anything to inventory or order service. So when the order is created, inventory service checks the stock we have, and then it comes to the order placed event. And when this event has been published, it will be subscribed by these two policies to decrease the stock and add the order to delivery list. And you can check what is compensation and correlation from the instruction over here. So when you take a look at the scenario, in this lab we're going to publish an event called order cancelled, which is being published when the customer cancels the order. And when the order is cancelled, we're going to carry out a compensation policy called increase stock, and it rollbacks the stock it has been decreased when the order has been placed. So for the event storming, we have added a cancel command, which is having a delete command inside, and this order cancelled event has been attached on the side of order aggregate, and it also has the attributes that are synchronized from this order. And we added a policy called increase stock and make a publish and subscribe line between event order cancelled and the policy, because when the order cancelled event is published, this policy subscribes the event and makes an action. So now, as we always did, click the code button here and we can check this order, inventory, and delivery code family has been added by the model we have here. And then let's move to Gitpod IDE. And as we always did, we have to install this Java language support. So install this and reload the page. And then I'll move on to Kafka folder and open a terminal to run the Kafka service by docker compose up. While it is installing, we'll move on to the main terminal and install this httpy tool. pip install httpy. Installation is completed and the Kafka server is still running. When it is finished, the Kafka server will be running on port number 9092. So the Kafka server is up now. Before we move on to the next step, I'll just separate this browser again and replace it like this. And so our next step is creating some codes. So following the instruction, I'll find the file called order.java and then move on to pre-remove part and check if the code is same as here on the instruction. If you want to check it better, just copy this and paste it underneath here, and as you can see, it's all the same. So you can check it like that. And let's move on to order cancel.java file. From here, order, there are some data coming from the aggregate order we have here, and I think it's exactly the same as it is on the instruction. And we also need to check the policy handler from inventory. So I'll find policy handler from inventory over here and check the stream listener part right here and check it is same as here. I think it is exactly the same. So let's move on, and we have this method called increase stock. So let's move on to inventory.java file and check if there is the method called increase stock. We need to fill out some code to make this method to work on the system. If you go straight down to the instruction, here are some additional instruction to put in here. I'll just copy this and replace it with here, increase stock, paste it, and our method logic has been added to increase stock. So we have done this, and our next step is to run the service by opening a terminal from order and inventory. And as we always did, Maven Spring Boot run. I'll copy this command to use it again on inventory, run it, and paste it here as well. So our services are both up on port number 8081 and 82. Now our next step is to move on to main terminal. I'll just clear this terminal. And our next step is to register a product. So let's move on to port number 8082 and get to inventories, and our product ID will be 1, and stock we'll put 100 amount of stocks. So it is registered now, and our next step is to make an order for product ID 1 and quantity of 3. So our order has been made, and to check if the order has been successful, we have to move on to port number 8082 once again and go to inventories for product ID number 1. Then our stock has been decreased by 3 quantity that we have ordered. And this is the next step we have done on here. It is compensation logic, so I will delete the order we made. If you put delete in front of port number and order, and if you put the ID of the order can be cancelled by the logic we made up here. The message called 204, it means that our cancellation has been done well. So if you check inventories once more, and I think there's something wrong on this logic here. We have to increase stock, but there is a minus over here, so I'll change it into plus and kill this terminal both and try it again. I'll run the Spring service again. So they're both up now. I'll just clear this terminal. And register inventory once more. And then here is our order command. So our order has been made by quantity of 3. And if you move on to inventory for ID number 1, our stock has been decreased to 97. And if you put in this delete code again, it works well, and we have changed the logic here into plus from minus. So I wish this has been worked well, and our inventory has been rolled back for the compensation rule. As you can see, the stock has been increased back to 100. So this lab had the contents of how to find the data from the event and how to implement the logic to get the cancel action that we have to put in to the system. This compensation correlation sounds very difficult, but it's quite simple as you have tried on this Gitpod IDE for the test. Our system has worked well by the cancel system we have added for the compensation, and now it's done.